Okay, thank you all for coming to today's event, Responsible AI, A Guide to the Future. My name is Laura Manley. I'm the director of the Technology and Public Purpose Project here at the Belfer Center. The TAP project, led by former Secretary of Defense Ash Carter and on the West Coast by Anya Manuel, is an effort to ensure that emerging technologies are both developed and managed in ways that protect humanity. Artificial intelligence is a foundational technology that's core to many of the emerging technologies that we as TAP study and evaluate. Therefore, we are so pleased to be hosting today's discussion with such a respected group of speakers from across the country, whom I'll introduce shortly. Today's discussion will address the following questions. What are the existing principles guiding the development and use of AI? What are the current gaps in AI governance? And how do we ensure responsible innovation moving forward? To give you a brief overview of today's event, we'll hear briefly from Secretary Carter providing opening remarks. Then Joey Ito, director of the MIT Media Lab. Then we'll break into a fireside chat with several experts in the field and close with an open Q&A session. Before I turn it over, I'd like to thank and acknowledge all of the other initiatives across Harvard and MIT that have contributed to this event and helped build the community of expertise on AI ethics. In particular, the Ethics and Governance of AI Initiative at Berkman Klein and MIT Media Lab, the Council on the Responsible Use of AI at the Belfer Center's Science, Technology, and Public Policy Program and Digital HKS. Lastly, I'd like to thank the TAP team and the Belfer staff for helping to bring this event together, despite the government shutdown. To kick it off, I'd like to turn to a message from Secretary Carter. Unfortunately, the Secretary was pulled for a last-minute obligation that could not be moved. He sends his sincere regrets, but wanted me to communicate his gratitude to all of you for attending this important discussion. Now let's turn to a video from the Secretary.
Good morning, everyone, and welcome. This is Ash Carter. I am here at the Belfer Center, where I'm the director and also an innovation fellow at MIT, and work with the excellent Laura Manley, who's here, and Anya Manuel, on the Technology and Public Purpose program, which is helping organize this today and sponsor it, which is the initiative that I wanted to dedicate after 37 years of defense, the next phase to, because I think it is the issue of our time, how we bring public purpose and the inevitable and very beneficial, but not always beneficial, march of technology into alignment. And my experience of all those years tells me that that's not possible unless technologists and policy people, and particularly technology community and government, don't work together. And rebuilding the bridges between those two was a big commitment of mine as Secretary of Defense. The digital arena is one of the important, not the only one, arena of rapid motion in technology and great consequence. And I think the discussion today on AI is devoted to a portion of that is the AI portion of it. Let me just recognize a few people who are here. First of all, I'd like to thank the members of the Defense Innovation Board who are here in their private capacity, led by Eric Schmidt, a great friend and a very, very much admired friend. And I got to tell you, as the person who created the Defense Innovation Board, I'm very grateful to all those people who agreed to serve, because it's a slice out of their time. They don't get anything. There's no pay or anything. They're giving it for free to their country because they believe that it is better to have a Department of Defense informed about what's going on in technology than not informed. Also, Joey Ito's here, my great friend and a Media Lab MIT colleague. Joey, thanks for being here. I'm sorry this came up. I got to do something this morning that I have no choice about and that is a lot less interesting than this. But I wanted to give you a few thoughts on the topic of AI and what I would have said if I were there in person, in this videotape in good tech fashion will have to serve as a proxy. First thing is this. I'll say something about defense first and then the bigger issue. First of all, the United States and we never made any apologies for this, takes our values to the battlefield. I thought that was very important. Joe Dunford, who is the chairman of the Joint Chiefs, all of my colleagues in the Department of Defense thought so. Importantly, the President Obama and all the presidents I worked for thought so as well. So no apologies about that. And that raises the question of how do you do that when you have AI-assisted decision-making? And an important technical criterion emerges from thinking about that. I would ask myself, for example, if I were Secretary of Defense and I authorized a machine-assisted military act, which we do already, machine-assisted, machine-enabled, maybe to a much greater extent than today. That's what will happen with AI. But and I imagine myself going out after a mistake was made or something tragic was done, like civilian casualties, and saying, don't blame me, the Secretary of Defense of the United States, or anybody else. It was the machine that did it. It was the algorithm that did it. I'd be crucified, and I should be, because morality is important. And that involves, in the case of AI, accountability. Now, knowing this way back in 2014, I believe, when I was Deputy Secretary of Defense, the COO, issued a memorandum, which is still DoD policy, that said that a human being will be involved in any use of lethal force by the United States forces. That's not the same as man in the loop. You all know that's not practical as a literal matter any more than it is today in a guided missile. But there has to be a human being who is accountable, and that's going to the public, to the leadership of the country. And by the way, that's going to be true everywhere. That is, wherever there's AI, there has to be enough accountability that a judge, the public, that we can situate our human values in the use of AI. Now, I know that is not an automatic thing when it comes to the algorithms that are used to constitute AI, that it is rather best described, that is enough transparency to ensure accountability. It is a design criterion for those who design those systems. And I would tell anybody who's working on those systems that you're not going to get it deployed, at least not in the United States, not by the Defense Department, but probably nowhere else on a sustained basis, unless it is designed in such a way that it can be explained in some human way how it happened, that what was assisted by AI happened in human and ethical terms. So that needs to be designed in the same way you design. I've been managing technical systems for 37 years, and you have to tell the engineers what it is they must do, and that is going to be a must do in AI, and that's going to be a technical challenge, but one that I think is manageable. Second thing I want to say about AI in general is also occasioned by starting with defense, but is bigger than that. There's a lot of talk about U.S.-China trade war, U.S.-China competition in AI, who's going to get the upper hand, who's going to get there first. And to connect with the theme of this conference, I would say a couple of things. The first is that with a little luck and a little management of the U.S.-China relationship, there doesn't need to be that kind of zero-sum strategic competition. I know it doesn't look that way now, and it doesn't look that way to me, actually, but we need to keep working in that direction. It does matter how well we are doing as a country. It matters economically, and it's going to matter strategically. And it's important to play defense from time to time with things like export controls and limitations on acquisition and certainly theft of certain kinds of intellectual property related to AI. But you can't win a war with defense only. We need to have an offense. And that really means more funding for artificial intelligence. And I think an important priority of the federal government, which is the traditional preeminent funder of R&D on behalf of public purpose, needs to have a big initiative to fund AI. The other thing the China case occasions is the question of values again. This time not about accountability and transparency, but about the purposes for which the technology is to which it's being put. And China is, avowedly so, a communist dictatorship. That means that so-called social scoring and social control is a stated value of the government. That is not a value of the United States government and most of the Western community of which we are a part. And I believe in those values. They're the values of the Enlightenment. They're what they called at that time the dignity of man, which we'd say dignity of humankind today. And so if you're working on AI and you believe that might come to be part of the surveillance state of China, you need to feel responsible for that. And so China raises not only strategic issues, but it raises issues of morality and ethics as well. I hope all this will be discussed today. Laura will catch me up on what is said. Again, I'm going to be doing something far less interesting than this, but not avoidable. And I'm glad to be with you to say what I've said in what, after all, for a tech conference is a reasonably appropriate way.
All right, thanks to Ash. I'll catch him up on the discussion after this. But to frame today's discussion now, I'd like to introduce our keynote speaker, Mr. Joey Ito. Joey is an activist, entrepreneur, venture capitalist, and scholar focusing on the ethics and governance of technology. He tackles complex problems such as climate change and redesigning the systems that support scholarship and science. As director of the MIT Media Lab and a professor of practice in media arts and sciences, he supports researchers at the Media Lab to deploy science, design, and technology such as AI, blockchain, and synthetic biology to transform society in substantial and positive ways. Thank you for joining us, Joey.
Thank you.
Who's going to switch this?
So I have the unenviable task of trying to give an overview with a lot of experts in the room. So I'll try to frame it and then get into some substance. But first of all, I think the word AI, just at a high level, is a kind of interesting word in that it used to mean those things that we cannot yet do. And suddenly now everybody is calling whatever they do AI. And so I think the word has shifted. It's kind of a suitcase word, as Marvin Minsky would say, in that it sort of means everything, so it sort of means nothing. So I want to sort of be a little bit specific about, I think, what we're talking about today. But this is just a small group of folks who helped me with this presentation, but they're part of my ethics and governance and AI project. But there's sort of 4 parts to my presentation today, so just talking a little bit about what AI is, some of the current issues that I think are important in the debate, some ways to frame how to think about these problems, and then a few of my efforts that we're doing at MIT and other places on trying to apply these frameworks. But first of all, I think maybe it's useful to not talk about sort of the futuristic, superintelligence, autonomous robot Terminator kind of AI, and to focus really on, I think, what is most important is machine learning, which is, and the difference between machine learning and traditional programs, which is algorithms used to be, and in many cases are still, lines of code that you can write and you can read. And so, for instance, when the Volkswagen scandal happens and there's code in there to make it behave a certain way, you can read it, you can dissect it, and you can point at the person who wrote the code. The biggest difference between machine learning and traditional programming is that machine learning is using code to allow a machine to learn and create a model of the world. And that model that it creates isn't deconstructible like lines of code. It's kind of like a brain. You can't rip open a brain and understand what the person thinks. You have to interrogate the person, ask the person questions. So that's where the explainability stuff comes in. It also is important to, I think, define the word algorithm a little bit. So in machine learning, there's a couple more steps. So a typical program, you would write a bunch of code, and then you would execute the code, which would be called the algorithm, and it would data would come in one end and decisions might come in out the other. In machine learning, there are two steps. So there's the learning process, which uses one or more of these machine learning algorithms to train the model. Sorry, it's a little bit small, but that branch up there is deep learning, which is the thing that we're all excited about right now. But it's just one branch of many, many branches that we've been working on for decades, and Danny and others have been there from the beginning. And it's not clear that it's the most useful in the long run. It's just the statistical neural networks to take things like pictures and then do pattern recognition has turned out to be extremely useful for the kinds of optimizations that are valuable today. And so a lot of what we say when we say AI, we're really talking about machine learning, and inside of machine learning, we're often pointing at one small branch. So what you would do is you would use deep learning to ingest a bunch of data like photographs to create a model that would then output classifications of the images, and so it would operate. I'll just add one thing. Sometimes people call the operation of a machine learning model an algorithm. So let's say you have a self-driving car, or you take AlphaGo. The algorithm to create the model is a huge process of taking data and creating a model. And once you have the model and it's in the car, or it's in the AlphaGo playing the game, it's no longer learning at that point, at least in the current instance. You actually just have a deployed model. Some people call that an algorithm, some people don't, but I think it's a little bit confusing because it's not the algorithm that's trained it, it's the thing that it's doing later. So it's as if once you left school you didn't learn anything, you just did whatever you learned in school, which some people do. And so this is the most common example of these deep learning systems is image classification. So this takes a huge number of images and has people tag what the images are. And after it's trained itself on a whole bunch of images, then it can take random images that are either in the data set, that part of the data set that was reserved for testing, or it takes real life images. And it gives you things that it thinks are in the image and levels of confidence. And this is what Google uses for image search. This is what self-driving cars will use to try to identify stop signs. And it's relatively accurate because we have a lot of images and it's quite fast. But one of the things that's key, and it'll come up a little bit later, it's not really clear how the machine knows that this is a mushroom, right? And this is one of the explainability peculiarities. Sometimes it turns out that they're looking at the background shade of a photo to determine something, or they might be looking at the collar of a shirt. And so we all look at, humans kind of look at certain things to determine what something is, but machines might be looking at other things. So they succeed and fail in different ways than humans. And a great example of this is a very controversial paper that came out a few years ago by Wu and Zhang, Chinese researchers who took a bunch of ID images, and sort of reflective of Secretary Carter's statements. And what they hypothesize, or they show using their data, is that they can identify criminal faces versus non-criminal faces by taking the ID photos. Now, there have been a number of criticisms. One, obviously, the privacy issues. But if you look, the three that are non-criminals, they all have collars, right? And the criminals don't have collars. Now, it's not clear, looking at the data, whether the machine was looking for collars, but it could well have been. Right? So then the attack on this would be, okay, well, if you're a criminal and you wear a collar, it won't identify. So the problem about explainability and the overuse of this, and this starts to get back to some historical things like eugenics, where we used to think that by looking at the shape of somebody's skull, we could tell they were a criminal. It's very reminiscent of those kinds of things. And so I think we have to be quite careful about how these machines are being deployed. And in places like surveillance, and I'll give a few more examples later, the sort of urge to try to use machines to solve these kinds of problems is very high. So I think we need to be careful. This is a work from Lab 6 is a group of students with no faculty advisor, which is kind of what I love about it. And this is an example of adversarial AI. So what adversarial AI is that you have an image classifier. So this is running against Google's image classifier. And by trying to figure out what sort of patterns it's looking for, it can try to trick the machine to think it's something else. So I think the video should work. So this is a turtle that will look like a rifle to the machine. So when you have a normal turtle, it's a 3D printed turtle. And so before they showed this with 2D pictures, and that they said, oh, well, this is real life. So there's a 3D printed turtle, and it looks like a turtle to the machine. But by changing the pattern on the turtle in a peculiar way, from every direction now, this turtle looks like a rifle to Google's image classifier. And what they've shown is you don't actually even need access to the algorithm in order to do this. So this adversarial attacks on image classifiers is starting to get better and better and better. And we don't really have an easy way to fix it, because you would have to retrain the whole model. And as I said earlier, there's this part of training the model and there's part of operating the model. And we currently don't have an easy way of updating what the thing knows later. So this is a real threat. And so you could imagine if you're on the battlefield and somebody has a camo pattern on their tank and they suddenly look like a lamb, it could fool. And so again, the human looking over the machine shoulder and the machine looking over the human shoulder is probably more than just important. The other area that AI is being quite useful, especially at images, is taking images from radiology and trying to understand them and identify them. And taking things like skin lesion tumors. But again, I think there's quite a bit of risk to this. Just recently, there was a paper that had, in New York, images that were categorized from one group of hospitals was used in another hospital, and it went from nearly 90-something% accuracy to 60, which is nearly random, just by moving to a different hospital. So again, an image classifier trained on a certain population or a certain type of demographic will suddenly become, will fail in a weird way when used outside. And so to frame a few of the debates that come up, and again, these are sort of the high-level things. First of all, this paper on machine bias from 2016 by Julia Angwin. She's a director's fellow at the Media Lab, and this was in ProPublica. But this was one of the early papers that highlighted this issue. And so she was looking at Compass, which was a company that created risk scores for the criminal justice system to try to predict recidivism rates. And the predictions showed that African American men had higher recidivism rates than whites. And so the judges, when they were doing sentencing, bail, and parole, would use these risk scores to determine sentencing or whether people were getting off on bail. So, and the company argued that they were accurate, right? So there's two questions that we come up here. Is it fair, just because it's accurate, that if you are black, you are going to possibly get sentenced longer or not get out on bail? And secondly, there's an interesting thing about recidivism rates, because recidivism is when you are arrested for a crime. So if you live in a poor neighborhood that is over-policed, you're more likely to be arrested than if you live in a rich white neighborhood where police don't arrest as many people. And so one of the interesting things about data is if you take the word recidivism rates or arrests and you say that's equivalent to crime, you're now sort of confounding things. And from the data scientist perspective, they say, well, we only have the data that the police have. But the problem is the police don't have crime data, they have arrest data. And so those sorts of things are quite tricky, and they tend to reinforce systemic biases that already exist and lock them in. Another one, this is from one of our PhD students at the Media Lab, Joy Bulling-Winnie. She shows that in almost all of the face recognition image classifiers, that white men have the highest face recognition rate. Women have lower rates. People with dark skin have lower rates. But women with dark skin have abysmal rates of sort of image recognition. And this is more representation. And again, people are testing these things on themselves. And so it makes sense that it sort of over-represents the people who are either in the population or working on these things. And so this is sort of a negative racial bias, and this is sort of a positive in the wrong direction. So these are things that we have to be aware of and think about how we preempt and change. Another really important piece is agency. So this is a paper about the use of machine learning in criminal justice, and this is a researcher named Burke. And he says the key line is, if other things are equal, shoe size is a useful predictor of recidivism, and it can be included as a predictor, right? So now we're not talking just about race. And he actually says if sunspots and shoe size correlate with crime, we should use those things. And so this gets back to the correlation versus causation. And so now this gets to agency. So it's not your fault if you have big feet. And if big feet then suddenly disadvantage you in the criminal justice system, is that fair, right? And there's a deep history in the sort of importance of agency in things like justice and things like fairness. And many of these things, when the statistical machine learning people look at it, it sort of gets glossed over and sort of falls prey to this very utilitarian statistical approach. So reproducibility is also very important. This was a recent Nature paper, and then this image was tweeted by Eric Topol, whose paper it was. But this shows some of the most highly cited and impactful papers in computer science that use machine learning to try to predict and understand things like septic shock and diagnose everything from dementia to chemotherapy. The thing that he shows in this paper and they discuss is that none of these have been clinically validated. It's not that people haven't tried. And what they're showing is they show very large numbers and very high accuracy in the computer science paper. And as computer scientists, and this is where I'm going to project my own view on this, they're trying to get tenure in computer science. So they publish the computer science paper, but there's not a lot of incentive for them to then go to the clinicians and try to help them apply it. And on the other side, the clinicians are like, hey, this is neat, let me try it. It doesn't work. And partially because they don't really understand exactly what the computer scientists did, and the computer scientists may or may not have been using a data set that actually works in the wild. So we're very excited about digital medicine. There's a lot of hype around it. But even the most famous ones have yet to be deployed in an effective way. So there's two questions. Does it actually work? Or if it does work, who's going to hand it over? So that's a question. And if we can't even do it in medicine where there's a lot of money, I think we need to sort of think about how ready this stuff is for prime time for other things. But it continues to be deployed. And one of a few examples that are kind of interesting. So the Samaritans was an organization in the UK that created an app that would go in and it would look at your Twitter followers, or the people you followed. It would read their tweets and guess if they're becoming suicidal. So it was looking for words that showed whether they were suicidal. And then it would warn you that your friend was saying suicidal things so that you could intervene. And they thought that was a cool service or a useful societal service to warn suicidal people's friends that they were becoming suicidal. But obviously it has weird privacy and vulnerability issues, and so it was pulled. Just, I think last week, a bunch of investors and some nuns went after Amazon because their face recognition software is now being used and sold to ICE and FBI and other surveillance uses. And they have questionable accuracy. And again, getting back to the facial bias. So if machine learning is being used to increase surveillance, but the explainability, the auditability, the control, and the quality of that face recognition isn't very good, it could lead to human rights issues. And they're concerned that we don't have the controls or the technology ready for that. This Boston public school thing is kind of an interesting failure that I was somewhat involved in, which was for years, so this is very pedestrian, but school start times and bus routes are notoriously hard to change. And a bunch of, and so the city, Boston did a challenge to try to get somebody to create an algorithm to redo this thing. How do you understand how the cost works and how do you re-optimize it? So a bunch of MIT researchers won the bid, and they created this system that allowed you to simulate and optimize for various things. And they did an amazing job of looking for trying to help disadvantaged families, trying to get high school students to start later because of new findings about neuroscience, about how much sleep they need, try to get kids, elementary kids home earlier, so for safety and all kinds of things. And they did a brilliant optimization, and they said, ta-da, and they opened it up. Now, it kind of makes sense, but a bunch of families got crappy routes. So they marched on City Hall. Interestingly, when you look at the picture, even though I think 85% of the population affected is black, all of the protesters are white. And because part of the equity thing was moving the traditionally privileged families to have slightly worse routes. But the parents did what they should do, which is if they got crappy routes, they went to complain. And then the mayor, having done so much work on this, and this was such a good proposal, wasn't prepared for this uprising. And actually, I was called by the ACLU saying, this is a terrible algorithm use, and the mayor's optimizations must have been optimizing for terrible things. So I even wrote an op-ed against the mayor's office, and then it was eventually overturned, and they scrapped the thing. But then later, the research from MIT came and said, you got it all wrong. We did the right thing, but it was a failure in the process, because what had happened was that a minority of people because there's always losers when you do an optimization. There are a minority of people who did the thing they were supposed to do, which is complain. And they were able to complain loud enough that it reversed this very important thing. And so one of the things that we have an ongoing conversation now with the researchers and the mayor's office of how do you involve everybody in the discussion of the trade-offs? How do you show the algorithm so that they understand what's going on? And how do you get them to buy into whatever the outcome is going to be because they realize it's for the better good? And the black boxness of a bunch of MIT engineers working with the mayor's office on some secret optimization, I think was what allowed this thing to be overturned. So I think this is kind of an interesting example where there's no bad actor, and it's not even that the technology was wrong. It was just a failure in our ability to interact with this process of an algorithm. Sorry, that was a little bit long-winded, but I think this is an example of how we might all do everything with good intentions but go wrong. Julia Angwin, again, who wrote the bias paper, her work right now is doing a really interesting thing, which is she's trying to quantify forgiveness. So if you look at insurance rates, this is one of the areas she's working in. For non-whites, the premiums are generally fair, so they kind of go up by risk. But for certain categories of white communities, there's suddenly a dip in price. And sometimes because there's sparse data, sometimes it's historical, but there's an unfair amount of forgiveness to people like the people who are doing things often. And it's kind of weird. So there's a societal impact in being overly generous to one community. So there's typically we're looking for sort of negative bias, but she's now trying to quantify the societal cost of unfair forgiveness, which is another thing that's often hidden. And you can use machine learning and AI to find these things, but they're also often built into the system. So some frameworks, and some of these may or may not be useful to some of you. Lawrence Lessig, who's a law professor, and in his book Code and Other Laws of Cyberspace, he has this, I call them the Lessigian quadrants, but I find these very useful, which is if you have a person or a thing that's being controlled, it's usually the regulation or what that thing is allowed to do is has 4 quadrants that affect it. So there's the law. So for instance, if you want to get people to drive slowly, you could put a law with a speed limit and police. Or markets, you can create incentives to drive slower. Architecture, which is the technology, as a law professor, he puts that under the law. But technology would be put speed bumps or something like that so that you sort of mechanically go slower. And there are norms, which is you just have societal norms in one way. The key thing is that you want to kind of work on all of them and connect them and use them together in concert. And I think one of the problems that we have in industry as well as in academia is that these 4 quadrants are often different disciplines, and they're very bad at talking to each other. Lawyers don't talk to technologists, social scientists don't talk to economists, and I think one of the really important things is how do we get these communities to talk to each other and to try to figure out how can we use cryptography to enhance a law that then creates a market incentive to change norms or something like that. And that being able to use all of them together and design things is, I think, very key. It's also not a new thing. In 1950, in The Human Use of Human Beings, Norbert Wiener, MIT mathematician and cyberneticist, he calls institutions, like the Department of Defense or a university, machines of flesh and blood. And we already have semi-autonomous systems, which are these organizations, and they're sort of super intelligences because they're smarter or maybe dumber, but they're more complex than individuals. And we have difficulty regulating them. We have difficulty with accountability. We have difficulty understanding why and how they work. And I don't think that machines are going to be that different than the machines of flesh and blood that we already have. And so, so at the Media Lab, we often use the word extended intelligence rather than artificial intelligence, because artificial intelligence sort of sets up this sort of tension between this independent, autonomous machine and a human being. But it's going to be, I think, completely integrated, just like technology is already integrated. I think bureaucracy is a kind of technology. These are rules and algorithms that control and affect our behavior and make decisions. And so I don't think that now, there are some categorical differences just as complexity goes up and speed goes up, but I think it's much less like suddenly there's a C-3PO that's going to be hanging by us as a wingman, and much more like we're going to get blindfolds and jetpacks put on us, and then we're going to start careening in the direction that we're already headed, and that we got to get our house in order before we do that. And it will just make every subsystem that is powered by machines more powerful and more difficult to understand what's going on, and increase complexity. So again, I don't think we can use the same solutions we've been trying to use in the past, but I don't think that it's just simply a new entity that's entering our system. And so I think, you know, what we want to do is we want to go back to first principles about why are we here, and how do we rethink things. The problem is you can't just scrap the current system and start from scratch. And I was talking to somebody who said that laws and software are very similar in that there is a low cost to adding features because people keep lobbying for more stuff. There's a very high cost to refactoring and trying to simplify things. And so everything, whether it's Windows Vista or the tax code, become this kind of bloatware because people keep adding things and making things sort of understandably complex. So it's very difficult to go back and reset to reframe the whole thing. And you have to think about how do you intervene in a complex system. And I think it is about trying to figure out how to set the goals. There's a great book that Martin Dempsey wrote with a historian that looks at the history of wars that America has engaged in. And none of them end on the premise of how they were started. So they all start and there's rules of engagement, but they all end for other reasons. And it's interesting because if the goals are shifting around, it's very difficult to figure out what we need to be optimizing for. I think the goals are set by the paradigms and the ideals as much as they are by the rules. So everybody knows the game Monopoly, but some of you may know that it's based on a Georges game from 1904 called The Landlord's Game. And The Landlord's Game was a game to try to teach children the perils of capitalism. And it was sort of showing how buying houses and having rent would drive people to bankruptcy. And it was trying to show this. And when Parker Brothers bought it, they just kept this one set of rules, the Monopoly rules, didn't change them, and just changed the goal. So now the goal is actually you win if you drive your friends bankrupt. And the point I'm trying to make here is that, you know, I think you can add a lot of rules to a system, but as long as your goal doesn't change, you're going to kind of figure out a way to get to that goal that you're trying to do. And so I think it's just as important for us to figure out as a society, what are the goals? And why do we have defense? How does statecraft work, and why do we have statecraft? And what are we trying to achieve? How does politics fit into all this? These higher order questions, and this is another Martin Dempsey point, which was that the politicians determine the optimization, the goals, but then the military are tasked with being ethical about implementing them. And when the goals keep shifting, how does that interaction work? So I think some of these questions are very important to understand if we're going to be directing machines to start enhancing our higher level functions. And I think it's important to understand that when these systems become very complex, they become self-adaptive. So if you look at the Earth, if you look at our bodies, we are able to get to some sort of equilibrium even without a central planner. So somehow when something shifts or changes, we adapt to the system. And so if you think about how do you intervene in a complex self-adaptive system, which society in ways are, is that it's often about figuring out how to change the evolutionary dynamics of the system. Donella Meadows, who was a researcher at MIT who worked for forgot the name. Anyway, she was a researcher, and she did a lot of the early models on complex systems like poverty and things like that. And I won't go through all this, but she had different ways you can intervene in complex systems. But the key thing is that the top 3 things that she thought, which are in reverse order because they're usually the things they're hardest to do, but the most important is the third most important was to change the goals of the system. And that changes the behavior of the system more than changing the constants or changing the rules. But the goals are set by the mindset or the paradigm. So in this case, it could be if we measure everything financially, and that we measure success by how much something is worth financially, that determines the landscape in which the game is being played. And so the goals of most of the things that are emerging out of the system is to try to maximize short-term profits and externalize costs. You can change the rules to try to create triple bottom line and try to put natural capital on the balance sheet. But ultimately, if you're still measuring everything by money, the goals are going to start to evolve in a certain way. The power to transcend the paradigm, which is what a lot of Generation Z is doing, is to say, well, I don't really care as much about money as I care about the environment, or I care more about experience. And so I think what's interesting to think about is, now to map this back a little bit to defense, would be when we used to have statecraft, and it was state versus state, and we had a clear delineation between state and business, for instance, that was a paradigm that we could develop a bunch of goals and rules around and optimize. But when you have non-state actors, when state actors are blending civilian and military, the paradigm has changed. And we need to think about how those paradigms affect the goals and everything like that. And so I think that's something that we, again, have to understand in the context of trying to design how we deploy these systems. And lastly, this is a term that I recently wrote an essay about this, but it's science and engineering try to reduce things to be as simple as possible because that increases efficiency. But it's always at the expense of either a minority population or at some kind of nuance. And the trick is to try to make it as simple as possible, but not simpler. And I think what we need to do is always check whether we're oversimplifying and over-reducing, because that difference of what we've cut out when we do the oversimplification is often the part that leads to the failure or the problem. And then the last section, I just might check my time. So we work with a lot of the companies. They're members of the lab. We're very involved in the partnership in AI, which was originally a consortium of corporations, but they have now board members from ACLU and civil society. And there are a lot of the companies like IBM and Google, and we work quite closely with them, are trying very hard to self-regulate. IBM is even making a business out of fairness and trying to sell software that looks at your data set to see if it's biased. Google has announced principles. They're our friends, they're working very hard, but I do question whether the corporations will be able to self-regulate, because they do have an incentive to reduce. And they do have an incentive to take fairness and possibly oversimplify it, make it a checkbox that they can just write an algorithm for and move on. And so I do think that we need to figure out how we interact with companies and how they are accountable to and with us. And in the academia, there's a whole field. So this is a field, there's a conference called Fairness, Accountability, and Transparency, with unfortunate acronym FAT. And they have a whole area that's focused on fairness. So if you go into the computer science department at MIT, you can walk up to computer scientists, and many of them say, well, I work on fairness. And so fairness has become a thing. But when you read these papers that are presented, they define fairness as like okay, we define fairness as accuracy, or we define fairness as some other thing. And fairness, I think, personally, is an ideal you can strive for, but you can't actually achieve fairness, because society isn't fair for everyone, and somehow we need to figure out how to build the irreducibility of things like justice and fairness into the conversation around algorithms. Otherwise, I think what might happen is it will be reduced to a science, just like actuarial fairness became what we call fairness in insurance. But this was a raging debate in the 60s and through the 80s, where should insurance actually be the same price for everyone? Should people who have shorter lifespans as a race category pay higher insurance rates? That was actually a question, but it no longer became a question once the mathematicians and the economists were able to reduce fairness to say, no, actually, actuarial fairness is fair. You should pay whatever your individual risk profile is. And so we've been okay with that. But I think we need to have a societal conversation on fairness. And my concern is with the emergence of a field of fairness in computer science, that it will end up with a somewhat computer science-y answer to fairness, which I think might be reductive. And so I think that we need to engage the social sciences, the humanities, and civil society in these conversations more. And then lastly, I have a research team called Humanizing AI and Law. And we're, a lot of the criminal justice, we're working a lot in criminal justice. A lot of this technology has been prediction. How do you predict crime? How do you predict credit problems? But what we realize is that prediction does two things. First of all, it takes agency from the predictee and gives it to the predictor, right? And the predictor is usually the one with the money, with the procurement, who buys the predictive policing systems or the recidivism scores. But what we realize is we don't really see long-term effects of policy, like ankle bracelets and drug tests. We don't know whether these things work. We don't have longitudinal data. We don't have data about whether the judges follow their guidelines in court. And we realize that the camera is always pointed down at the people. And so what we started to do is point it up. So we've started collecting data on do these things work in the long run. So we're thinking more about causality rather than just correlation, trying to understand whether laws actually work, and trying to understand the system, model the system. So machines can be used not just for prediction, but they can be used to try to understand these complex systems and look at the impacts of policy and things like that. So we've been trying to do that. We launched a recent collaboration with the IEEE, which is the largest sort of association of engineers, to try to get the idea of social responsibility into engineering through standards and things like that, because they're a very important community to talk to. And lastly, we created a fund with Reid Hoffman and Piero Midyar and Knight Foundation to fund research in the area of AI ethics and governance. We started this in 2017. And you know, I think it was, one thing though I think that is interesting to note is, I think it was 2016, I think, when President Obama asked to come and be briefed and talk about this, and it was also when the Vatican asked to talk about this. So I think around 2016 was when the world leaders decided that AI and ethics was an important thing. And it was around 2017 that we started seeing more and more funding being deployed. That's when we started our class. And I do think that we're sort of turning a corner, where we're seeing a lot of people engaged in the conversation, and we're starting to, it's sort of just in time, because we're starting to see the actual failures happening. So I think we're kind of at a very pivotal moment where fairness was really just a thing that a few computer scientists worried about in the back of their head, to where we see heads of tech companies being dragged in front of Congress, and we see a conversation like this with a Defense Innovation Board. And so I think we're in the right place at the right time. Thank you very much. I can do a few minutes. Yeah.
All right, so we have a question from the audience already. The question is, bias seems to be an inescapable problem that will always exist as a result of our own human nature. Is there a way to identify bias and trigger quality control or rework of the machine learning?
So I think the tricky part about bias, even before we get to machine learning, is what do we do when we find it, and what do we consider fair? So there was a Spotlight article in November, the year before last, that showed that the median net worth of a non-immigrant African-American family in Boston was, I think, $8. And a white family was $247,500, right? So you have this fundamental inequity, right? And then you have things like, we have rules around redlining, which is unfair districting of services. But then you have somebody like Amazon coming in saying, okay, we'll offer Prime to neighborhoods that have wealthy people, because that's what that's marketing, right? And so then it gets kind of fuzzy, right? So what caused the inequity in the first place? And there's a lot of history around house buying and things like that. And then you have this historical inequity that creates a fact, which is unequal wealth. And then you have a marketing system that then goes and says, well, we want to market to our people. And so I think the question a lot of this stuff is what do we as a society determine is fair? So it's interesting too, because right now it's 1969 was the year of the Detroit riots. It was the year of the Summer of Love. I think it was around 1968 or 69 that redlining had always existed. But it was around 68, 69 that they decided that it was actually an issue they needed to talk about. So similarly, I think what's happening right now when we have a very divided society with a lot of angst and anger, I think it's actually an important time to have conversations around what kind of bias we think, because there's always discrimination. Some people get hired, some people don't. Some people get loans, some people don't. What kind of discrimination do we as a society think is okay, and what isn't okay? And what I think is really important is to start to allow society to understand the decisions that we're making when we have things like credit scores that can send predatory ads, and so this is, a lot of this is a literacy thing, but I think what's really important is that if, as long as Ash Carter was saying, as long as we're a democratic society, these decisions should be made by society and not by the engineers and not by just a bunch of lawyers. And so I think that part is really important. And then secondly, people like Julia Angwin are really important, because these are investigative journalists who find biases that even the people who created the software don't know. The insurance companies didn't know they were being unfairly forgiving. Facebook didn't know you could buy ads for Jew hater until she found it, right? So the other part is the role of journalists in this, and data journalists. So I think data journalists like Julia Angwin are the ones that find the weird biases that everybody realizes is bad, but they don't notice it unless you find it. And using AI to look for bias, I think, is really important as well.
Okay, how do we best establish international norms for the application of AI when other countries have different values? Are cyber warfare and nuclear deterrence our best references?
Yeah, so again, I think it's, again, as Ash was saying, I think it's really different when the fundamental norms of our adversaries are different. You have the non-state players, you've got states that are really different. I think, for instance, China is a great example of where they don't even understand why you wouldn't mix business and government interests. So you can't even, that just seems like, it's like, well, you guys are still doing column marching in red suits and we're doing guerrilla warfare, but just catch up to us. So I think that's a really hard conversation if you can't have the conversation. And I think that's kind of where that's sort of what's gets back to my paradigm thing. And so I think there's a really interesting and important conversation about how do you defend yourself in a system where the rules are different depending on who the players are. There's not an easy answer. I do think focusing a lot on defense and resilience is really important. I think that it's kind of like climate change in a weird way, in that you want to do mitigation, but you also have to do adaptation. So you kind of have to prepare for failure, but then try to implement things to eliminate the failure. So you have to do all of them. So it's sort of a non-answer answer. I don't think there's an easy answer. Thank you very much.
Okay, so next I'd like to welcome our fireside chat speakers to the stage. Okay. The Defense Innovation Board initially planned an event for today's date, but due to the government shutdown, it was unfortunately canceled. However, we are taking advantage of their presence in Cambridge today, and they'll be speaking in their personal capacity. So we'll do brief intros, and then we'll kick off the discussion. First, we have Danny Hillis, the co-founder of Applied Invention. Dr. Hillis is the co-founder of Applied Invention, an interdisciplinary group of engineers, scientists, and artists that develop technology solutions in partnership with leading companies and entrepreneurs. He's also the co-founder of Applied Minds, visiting professor at MIT Media Lab, and professor of engineering and medicine at USC, among several other academic appointments. Previously, he was the VP of Research and Development at Walt Disney's Imagineering, where he developed new technologies and business strategies for Disney's theme parks, television, motion pictures, internet, and consumer products. Next, we have Milo Medin, VP of Wireless Services at Google. Mr. Medin has been part of the internet development community for more than 25 years. He is currently the Vice President of Wireless Services at Alphabet, where he oversees the company's gigabit fiber in home projects and other efforts to improve internet access. Prior to joining Google in 2010, he founded and was Chief Technology Officer for several companies, including M2Z, Networks, and Excite at Home. Previously, Milo spent years working at NASA's Ames Research Center, where he managed the primary West Coast interconnect for the Internet and architected and managed the global NASA Science Internet. And lastly, we have Richard Murray, Thomas E. and Doris Everhart Professor of Control and Dynamical Systems and Bioengineering at Caltech. Murray's research is in an application of feedback and control to network systems with applications in autonomy and biology. His work on autonomous vehicles includes advances in nonlinear control theory for real-time optimization-based trajectory generation and tracking, Some of his current projects include synthesis of discrete decision-making protocols for reactive systems and the design of highly resilient architectures for autonomous systems. So thank you so much for our esteemed panel to be here with us today. I'd like to kick off the conversation just asking you, if we take a look 10 years down the road, how do you see the impact of AI on society? And we'll kick it off with Danny.
So, it was funny, Joy introduced me for having been here from the beginning, which was not quite fair, but I did get to study under people like Marvin Minsky and Claude Shannon, who really were there from the beginning. And so I've kind of watched several of these cycles where people, there's an advance in AI, and then people begin talking about AI ethics, and then kind of see how they play through. And I think one thing that happens is that people get very enamored about a particular technique. And so they start defining AI as that technique, and then they start extrapolating a whole bunch of things of that technique. So the current technique is exactly the one that Joy described, which is statistical machine learning. And I think he had very intelligent things to say about that. But my guess is 10 years from now, that's not what we'll be talking about. I think we'll see that as a very limited technique. And it will have some impact. It will cause some jobs to change. It will have some shifts. But there'll be other things in AI, I think, that we'll see as having bigger impact by that. And so, in fact, AI, as Joy said, is kind of a suitcase word. It's a bunch of things that humans do to be intelligent. Pattern recognition, which is what this learning about is one of them, but I think it's not the most important one. I don't think it's the highest impact one. So I think that we will see impacts from it, but my guess is we'll go through another cycle of people being sort of disappointed it was all overhyped, and then there'll be another breakthrough, and then they'll see it as much more important. And we'll go probably through several cycles of that, each time actually making genuine progress and having machines become more complicated, making more decisions. And so we're going to take it in a series of hits and adaptations, and this is kind of one of them.
I think you're going to see AI, or machine learning specifically, be marbled through all sorts of devices. That is to say, sort of what I think of as tactical use of AI, where we take our existing processes, our existing ways of doing things, and you make them more efficient, you make them more effective. And in that way, a lot of the impact will not be immediately obvious, right? The real question that I think prompts a lot of worry or optimism, depending on your viewpoint, is what about strategic uses of AI, where we can actually completely change a process, do things in a completely different way. And that's going to depend on, I think, new techniques showing up. It's also going to depend on more data being collected and being available. Because you cannot be a leader in AI without being a leader in data. You have to have data to train systems. And without that, or you have low quality data, or you have biased data, your AI is not going to give you the sort of benefits that you want or trying to get from the system. I do think you're going to see tools develop that will take some of the sharp edges out of taking machine learning and AI and using it effectively. Right now, there are a lot of sharp edges. You can use the sort of TensorFlow and other sorts of things, but the question about what are you trying to optimize for? How is there bias in the data that's being fed in? How do you do labeling effectively? What's the compute infrastructure that you have available to do this, right? A lot of those things have a lot of things you have to get right, and they're not immediately obvious. So I think one of my concerns is that you end up with people using machine learning in ways that are not particularly good and causing a lot of problems that could have been avoided if we had better tools and better technologies for that. And I think, globally, different people will use these techniques and may not be so worried about some of the problems. We care deeply about that in America. That's not necessarily true in other nations. And so the challenges of making technology widely available, you don't get to control how it's used when it's pervasive.
So I think there are a couple of things. I think that one of the things that we'll see is that AI becomes ubiquitous in the way that we interact with digital information. That essentially there'll be more and more digital information out there, and the information that we see will have gone through some type of AI technology. I'll sort of use AI sort of broadly to capture all of those sorts of technologies that go along with that. And also, we will communicate back, and in some sense we already do through AI technologies, that when you send email or speak to somebody or whatever, an AI technology will process that information and decide what to do with it. So I think that's one thing that we can anticipate will be there. And again, we already see a lot of that, what appears on your Facebook feed and other things already going through these sorts of algorithms to do that. I think the other is that we'll see, in 10 years that AI-assisted decision-making, and Secretary Carter talked about this, will be something that we also see, that you will make a decision based on what an AI engine suggests to you might be the thing that goes on. Right. And there'll be some missteps there, right? I lost a bunch of money because I trusted that AI algorithm, right, and it sort of screwed up. Or, I should have listened to my friend instead of, right, sort of making use of whatever my email thing suggested to me I should do. The last one I think is, harder to predict is what will happen with AI-enabled machines. That is, where now there's not a human making a decision based on information provided to it, but rather a machine making a decision without a human perhaps involved at all. Self-driving cars being one that we're sort of seeing, but lots of different places where you can imagine AI technologies having to make a decision. That one's harder, and I think we will probably see 10 years from now that we're starting to worry as a society about should it be regulated or not. Again, I'll take self-driving cars. They're gonna do some things that a human wouldn't do. They may or may not be safer than a human would be driving a car, but we're going to start worrying about, well, who's making sure that those are doing the right thing? So I think that's one possible way that all of this will look in 10 years.
And I think playing off that question, as we're looking towards the future, what are the biggest risks to society that you're concerned about, and how do we mitigate those risks?
So I think that the biggest risk to society is that we increasingly actually don't understand our technology. So that we use, and that's not just AI. I think AI is a particularly obvious example of it, but we don't really understand how the internet works in detail, for example. So more and more, it used to be that there was a distinction. Nature was something we didn't understand but kind of took advantage of, and we had ways of tweaking it. But the beer maker didn't really know how the yeast worked, right? And technology things were machines, and they did fairly simple things, but they were very predictable but very limited in what they did. Now we're beginning to blur those two things. We're beginning to engineer nature, and we're beginning to make these things like AIs, which are adaptive and use natural techniques, and our relationship to them becomes more like a relationship with nature. We sort of can kind of nudge them to do what we want, but we don't actually fundamentally understand how they work. And so that's a very different relationship with technology, and I'm not sure that we've gotten our head around that yet. So I think we still assume, probably, I think many people assume that there's somebody who understands that system. They know they don't, but they assume somebody else does. But actually, I'm pretty sure that many of these systems, there is no somebody else that understands them. And I think that could be an existential risk to society.
Yeah, I think this nature of what is the algorithm or what is the model being optimized for? And do the people who are using it understand what the optimization is designed to actually do, right? It's funny you say, a lot of people don't know how the internet works. We built the internet in a way that you could use it without actually understanding how it works. In fact, that was the key to its proliferation and success, layering and a variety of mechanisms. AI is not at that place today, where you can use it without really understanding what you're trying to do in terms of training and models, et cetera. And this poses all sorts of interesting questions. So, for example, I had a conversation with a friend of mine in the Department of Justice. Price fixing is illegal. Well, what happens if you have a set of companies start using AI models to set pricing? And you say, my optimization is to maximize profit. Well, would that naturally lead to the models generating cooperative price fixing? Well, that would be illegal if human beings communicated with each other or did things in a way that would do that. But if the model naturally did that, is that a violation of antitrust? The model's trying to optimize for profit. Well, that's what it did. It didn't do it, and you didn't tell me not to collude, right? How do I not collude? This nature of what you're trying to optimize for, and how do you take values which may be not explicitly stated and incorporate them in the training process is going to be a challenge. Mm-hmm. And when you don't do things, you get a model that's optimized for a particular thing. Guess what? It's only optimized for that thing. It's not optimized for other things. And people using that are going to be a problem. I think another thing that I worry about is, we had some discussions about this recently. If you say there has to be an off switch, a red button that you can say disengage the model, right? That presumes that there's enough margin in the system that whatever the optimization that the model gave you, the reason you deployed it in the first place, is available. So let's say we use a bunch of ML systems like Google's done on its data centers, saved a bunch of electric power, and that becomes proliferated. What if everybody had to turn it off because of a particular failure? Is there enough power in the grid left to actually operate without the optimized model being in place? And these sort of subtle dependencies can create fiascos because we don't actually understand where those dependencies are. Humans are actually pretty bad at this. That may be actually an area where AI can actually be helpful in flagging dependencies. Did you know that these things are correlated, and you should pay attention to that?
Mm-hmm. Yeah, I'd agree with what Danny and Milo said. I think another thing to think about in terms of risks is the unintended or unexpected consequences of where we go with AI. There's going to be a huge demand for having more and more data, for correlating all of those data. One of the things that happens when you do that is that your ability to be anonymous goes away because there's just so many things that can be correlated with what you've done and other things. And so what happens to society when we lose that ability to effectively sort of be private? And what are the consequences of that? I think as we start to categorize people and countries and other things, right, using all of these mechanisms, do we lead to more balkanization and polarization of society and other things through the use of these AI technologies? I think that's a risk. We see that already happening, just with communication technologies and other things, where I think an unintended consequence, right, was the ability for fringe groups and others to say, hey, I'm not a fringe group, I'm with a bunch of my friends, and sort of go down that path. Maybe AI makes that worse.
So how do we deal with all of these risks? What's the role of policymakers? I mean, we're sitting here at the Kennedy School with so many people that have either been in government or are going into government. What's the role of civil society? What's the role of business to deal with some of these risks?
So I think one important thing is that traditionally there's been a separation of the design of the, if you will, the social infrastructure, the social systems, the political systems, have been done by different people than are doing the technology. And those have been, and I don't think we have the luxury of doing that anymore. I think the systems that influence our lives are a combination of those things. They're a combination of the underlying technologies and how we use them, and how do we decide fairness, and what goals do we set for these systems and things like that. And I don't think anymore we can do those as independent activities. I think that they need to be worked on together.
Yeah, I think I think of there's a group of people and companies that create technology, and then there's a different group of people, sometimes they're the same, but oftentimes a different group of people who use that technology to accomplish a particular task. Being able, having principles applies to how you use technology. So I can imagine a set of principles that, like Google developed for AI in terms of its use. I think having each sector understand sort of what guardrails do you want to put in the system in terms of staying true to established norms or regulations, right, is going to be important. I think on the technology creator side, it's interesting. A lot of work is going on in the open source community, et cetera. And when you do that, you don't actually have control over what that technology is used for or by who it's used, right? I used to work on nuclear weapons at Livermore Lab when I was in college, and we never open source warhead designs, right? I mean, those were a very discrete group of technology development, and we shared technology, sometimes with progressive action locks and fusing mechanisms, but with others because we wanted them to have safer nuclear weapons. But that was a very limited set of interactions. It's difficult to put limits on technology that's pervasive. If you want technology to be pervasive, it's very difficult to limit its application. And so I think that's one of the stress points between government, industry, academia that is going to get worked out. And of course, speaking from the defense perspective, those are all very distinct sectors in the United States. But those are much more integrated in other countries, like China, for example. You don't have those same set of differences. So it will be interesting to see how that evolves.
Yeah, I think big picture, society has to figure out what are the legal frameworks that it wants to use, what are the ethical frameworks that it wants to use, et cetera. How does society figure that out? Well, government plays a role,
right.
Industry plays a role, cultural norms, how do those come about? I think it's complicated, but eventually we're going to have to get to the point where we say we are comfortable, right, with an AI technology doing the following things, collecting the following information, sort of making the following decisions, and we're not comfortable with others. As Milo says, that's going to get, I think, challenging because we could decide one thing in this country, other countries can decide different things. It's a global marketplace. It's global data in some sense. The data, the streaming that's being done. What countries is that going in? Right.
Can I actually just pose, for instance, a specific example of how this comes up in DoD? So, for instance, there have been people who posed the principle that we should never have, we should always have a human in the loop. And it sounds on the face of it like that's really good. We would like to, I think as Secretary Carter said, always have a human that's accountable if, for instance, lethal force is used. But let's say that we have, it's very easy to come up with systems that we can look at and say, we could, by taking the human out of the loop in this system, we could actually have less chance of causing collateral civilian deaths. So now, in some sense, well, you violated what sounded like a great principle, but the practical, let's posit that the practical result is fewer civilian casualties. So all of a sudden you sort of have a sort of conflict between a very practical question, which, are you going to let people die to stand up to this sort of abstract principle, or are you going to make the machine safer? Are you going to make the system safer? And I think those kinds of questions are, not just hypothetical right now.
I think the other thing about this is that I think society, humans are willing to tolerate a different, they put different standards on what humans can do and make mistakes about and what technology can do and make mistakes about. So I'll bring up the issue of self-driving cars. I think we can probably make self-driving cars that are as safe as humans, human-driven cars, but they will make different mistakes. They will have an accident and somebody may get hurt in a situation in which you would say, how could that possibly happen? It was
Right.
so obvious that. Of course, it wasn't obvious to the computer in the way that it represented it. On the other hand, it will have not had an accident in hundreds of other cases that a human might have, but those are invisible because no accident happened, right? So statistically, they're doing better, but when you look at the specific cases where something bad happened, you go, that's stupid, right? How did that possibly happen? How do we get our hands around that, right? And again, this issue that, how do we have a conversation around the fact that on balance these are better, but when you look at a specific instance, and again, Joey pointed this out as well, that you sort of look at it and say, well, those bus routes are stupid, right? But in fact, they're better for society overall, and I think that can happen as well. So I think those are challenges.
And by the way, that happens. Those kind of trade-offs can happen without AI.
Sure,
right? We have plenty of autonomous systems that are not machine learning derived, right? Autopilots on aircraft, et cetera. So we already have some of those problems. That's a general issue with autonomy.
Right.
But that autonomy and AI are two different things, and sometimes people convolve them in ways that I think are unfortunate.
So considering all of these challenges and switching gears a little bit, what does an overarching AI strategy look like for the United States? What kinds of principles would it include? What kinds of guidelines?
You assume that there's such a thing as a national strategy. The U.S. doesn't do a strategy well, right? That sounds like industrial policy, which U.S. is generally not.
Well, should we have one, right? Because China has one, several other countries are developing them. Should we have one in the first place? And if so, what does it look like?
Well, I think it makes a lot of sense in particular sectors to say. I mean, for example, let's look at what was done in the stock market with program trading. And people looked and said, hey, there's a bad consequence that these fast trading machines can have an emergent behavior that's bad for everybody. So we need to put in circuit breakers. And so now we have circuit breakers in the market that turn off the programming trading in certain circumstances. So there is a case where somebody looked at the application of technology, looked at some societal needs that weren't being well served by that, and came up with some coordinated policy. So I think we will see, or we should see that happening with AI. And I think, for instance, looking at how do we use AI, how do we use it responsibly and ethically in Department of Defense, I think that's a very good
And who
thing
decides?
to be doing, and I think that will result in some mistakes not being made, and some better things getting done, and so on. So I think that makes sense. It's not sort of a global policy on AI, and I think that one of the things about AI is, by its nature, is so multidimensional and done by so many different people in so many different ways. There's no kind of regulating it in the way that maybe nuclear weapons were regulated or something like that. That's just not on the table for it.
Yeah.
So I think it's going to be, if you will, a kind of local coping mechanism that in particular areas, I think we have to look at the technologies we have and ask the questions about not just, it's not going to be simple rules. I think we have to treat it as a complicated, difficult, nuanced thing and go through the work of thinking through how we deploy the technologies, and then I think we have to look at the effects of how we have to assume we'll make mistakes, look at the effects of it, kind of measure the effects. Is this behaving in a way that we think is unfair or something like that, and be willing to correct our mistakes.
Yeah, so I think consistent with that, I don't think we can have a national strategy for AI. Maybe we think about having a meta strategy. How do we create an environment in which AI can flourish? And so for example, I think one of the things that will be a little bit limiting is the types of ways that we collect data and the sorts of data we can have, and privacy concerns and other things are going to make it hard for some types of AI to advance as quickly here as they might in other places where those constraints don't exist. What do we do about that, right? And the U.S. government say it's important to do that. In a kind of self-serving way, just since I'm an academic, you could imagine saying, well, scientific data might be a great place to go and, sort of train AI technologies and do other things. So let's collect and make much more open and develop tools for doing science with data. And then maybe those tools allow us to do things. And there's perhaps not as much concern over collecting scientific data about the universe or fundamental particle physics or
Right.
kind of molecular biology as there might be about collecting personal information about us. That might be something that we do. Or we might say that I think there's a real tension right now with the type of research that goes on in industry versus what goes in academia. Universities are having a hard time keeping AI faculty members because there's such a demand from industry to do that. That's great. But if we want to be training that next generation of people who are doing that, we also need some of those stars in AI to maintain their connections to universities. Maybe the U.S. government can help facilitate that some, right, by creating robust funding mechanisms on other things, right? Where you say, I could go work for Google or I could go work for Facebook, but I really want to stay in a university because I'm able to do things and it's such a great environment and I have great students and other things. Or I do both, and that's also something that's getting done now. So I think the government can kind of try and set up the ecosystem for advances in AI that allow the U.S. to continue to be a leader in that area, as I think we are now.
Yeah.
But I think there's also an issue of norms, too. So because it's a relatively new thing, I don't think that we have developed the habit of when we deploy a technology, asking, does that technology align with our ethics of how we want to behave, our values, our ethics, and so on, because mostly the technologies haven't been complicated enough that we had to ask that question. And so I think we have to develop a societal habit of asking the question that, I think both Secretary Carter did in his meeting, and Joy was asking, that when we deploy a technology that is making decisions on our behalf or informing decisions or influencing decisions, I think we have to develop the habit of asking, is this making decisions in a way that's compatible with our beliefs and our value system?
Yeah, and I think it's easier to do that analysis when you're talking about what I refer to as sort of tactical use of technology, of AI. So for example, you have a pilot who's engaged in an air combat situation. He pulls the trigger on firing a Sidewinder missile. If the missile seeker is using AI, computer vision technology, to improve its ability to deal with countermeasures, what are the real ethical issues around that, right? It's already in a particular context, lethal force has been, a human operator initiated that. I'm now just using the AI to improve performance in a particular system. Or I'm going to do predictive maintenance of engine failures, right? So I'm going to go through my logistics and supply chain systems, and I'm going to be better in terms of, that's going to result in aircraft uptime being improved. Those kind of uses, the tactical uses, things we already do today, where we're doing things in ways that are not enabling a new technology, but simply doing what we're doing better, and there's already a set of guidance and principles that are being used, I think are easier problems and less controversial.
I think they're easier, but I still think we have to have the habit. Because you might say, well, what are the ethical issues in pricing insurance? People might have asked. Well, actually, it turned out, when you really thought about it, there were, but maybe people didn't realize.
Yeah, that's fair.
And so I think as we develop these other ways of making decisions, I think we need to develop the habit of asking the question, does it? And sometimes the answer will be no, that there's not a problem there.
But even if we do that, we're all circling around the same kind of question, that we need to be thinking about if it's compatible with our values. But whose values are we talking about here?
Well, I think that is, of course, a much bigger question than technology. How does our society figure our values? But I would argue that while there's certainly many edge cases and our values evolve and so on, there are some core values that are pretty constant. They're probably different here than they are in China. So there's, that is something, that's a problem society is already working. How do we evolve our core values? How do we improve? I do believe our core values are not a constant. I actually, I do believe in moral progress, not just technological progress. So I think our core values are refined and get better over time. There is an arc of moral progress, and so that's a moving target. But And so we have to sort of make sure that our technology is calibrated, and that's become a more complicated issue in a way that we don't quite have the habits of yet.
Right, right. So if you want to just provide closing remarks, then we'll make sure we have enough time to give people a chance to provide public comment or ask any questions. Does anyone want to kick it off?
I'd rather have questions.
Yeah, I would just say one thing, you know, certainly from my perspective dealing with the Department of Defense, it's interesting. One thing I would like people to know that they probably would be surprised by is that the department really does not embrace automation, right? So the whole point of autonomy, I laugh at when people talk about killer robots. It's amusing to me because the department uses people to do things like watch gauges and watch displays and take action that we in industry completely automate. And so there is a huge aversion in the department to actually automating things that you would take for granted in any other sector. And so I think their willingness to trust AI, particularly in weapon systems, et cetera, is actually very, very low. There's a natural bias against that, partly driven by the sort of poverty of compute and communications that they live in, but also just the social context of how they think about people. So I don't look to the DoD to be the leaders in deploying AI in weapon systems.
To give you a specific image of that, if somebody turns the wheel on a nuclear submarine, what happens is that they move a dial that goes down to the engine room, and people look at that dial and start adjusting things to shift the submarine. I mean, that's the level of people involvement that
you would be surprised. Yeah. Right.
Yeah, so I think the last thing I'd maybe leave people with is just, you know, there really has been a shift in what the technology can do. And, you know, I think you see this in things, you know, voice recognition is the one I usually like to use, speech recognition. You know, people work for decades to try and figure out how to get it to where a computer could understand what somebody said. And, you know, just the techniques that were being used, et cetera, just, you know, they were sort of stuck at not very good levels. You know, you would talk to a phone system and you had to say yes, and then it wouldn't understand it, and you had to say it again, all this stuff, right? And, you know, I think deep neural networks and other machine learning technologies, the amount of data that was available, the amount of compute that was available, you know, we just crossed a threshold. And now these things work vastly better than the previous generation systems.
And language translation, I'll go down the list.
Right, there's a long list. So we should think about what that means. You know, we've sort of made this, maybe it will stay at a plateau for a while, but even at that plateau, there's a whole bunch of things that are now possible that weren't possible. And there may be at another you know, hump that comes 10, 15 years from now that takes us yet to another plateau. So I think it is a time when we do need to be thinking about, you know, what are the consequences of all of those technologies and how might we use them.
So I just want to ask for a round of applause for our speakers. Thank you so much. So now we'll open it up for a public comment and question. There are microphones here on the side, so feel free to just get up and ask your question or pose your comment. And could you please just introduce yourself before? Graham.
Hi, I'm Graham Allison. Excellent presentation. Thanks very much. So if you were looking to the question of applications of AI in the military and security realm, in the competition between the US and China, which are the next ones up you would expect in the next 3, 4, 5, 10 years?
Well, so I think, you know, one that you'll see on the military side and already are seeing, so, you know, on these kind of classic hard problems was automatic target recognition. We've been working on that problem forever, and it's been terrible. And now there are enough data and enough compute that countries can go and say, find that thing, and that can be done. And so I think that'll have ramifications as people start saying, great, why don't we put that inside of a military system and have the military system go off and make use of that. You know, I think on the US side, we'll think about, but a human needs to be responsible for that and other things, and I don't know what the decision will be, right, you know, for other countries and how they do that. I think that those technologies are ones that, you know, as Milo sort of said, the U.S. is not doing nearly enough in terms of collecting data that it already has. It just throws it away.
Right.
And so it's not able to advance those technologies as quickly as it could. I don't know what China's doing, but if I were them and if I were us, I'd be collecting all of those data and making use of those data and thinking about how that could improve the effectiveness of those systems.
I would say, you know, there are some areas that I think you've got the ability to really make an impact militarily quickly. ISR is one of them. The amount of video...
Fill out your acronyms.
Intelligence, surveillance, reconnaissance. The ability to... Right now, there are thousands of humans who look at video for hours at a time, looking for things. And that process is what they miss and what they find is critical to what action people take. Being able to use computer vision, which is relatively mature, and cue for a human being certain things that are interesting. Not replace the human, not do automatic targeting, but simply cue the human to look at this, right? I think could make a huge impact on the lives of all those soldiers, airmen, sailors who are tasked with that function. I think cyber is another area. The ability to look at what's going on in terms of attack, coordination, what's going on your own infrastructure, right? Looking at network traffic, and again, cueing a human that says, hey, this particular thing is going on. We are really quite poor at doing this, but you know, large companies do this. We use that in our infrastructure as part of defensive actions. So there's any area where you've got large amounts of data that humans have to correlate in ways that are painful and labor intensive are sort of immediate applications that I think could be significant in their use.
Yeah, my suspicion is the biggest of those is going to be logistics. That's going to, in the near term, that will be the big one.
Yep.
Yeah.
Hello, my name is Greg Allen. I'm a fellow at the Center for a New American Security. It's a DC-based think tank that does a lot of work on AI and global security issues. I'd like to react to one of the comments that Milo made, which is that it's difficult to regulate a technology that is ubiquitous or to control such technology. This is, of course, true, but I think that the technology industry is excessively using this as an excuse for inaction and something that we should be quite cautious about. A few examples come to mind. The counterfeiting world is using many ubiquitous technologies that have controls built in. If you try to photocopy a dollar bill, the photocopier will reject the attempt to copy it. Photoshop software will refuse to edit images of money. So my point is that there are sometimes worthwhile controls that you can put into certain technologies, even when they are ubiquitous, which may not solve the problem, but can still nevertheless be helpful. And this is an incredibly timely issue. The Department of Commerce is currently considering export controls related to AI technology. And so we are asking ourselves, are there limits that are worth putting on? And of course, we're running into this problem that AI is a dual-use, general-purpose capability. And so we're asking ourselves, what is the right thing to control? And I think this ubiquitous issue should not be used to say that there should be no controls. There are some applications that are so nasty that even ubiquity is not an excuse to try and not prevent them. So I think, for example, of recent work on bioweapons, where there was a Dutch laboratory that published the DNA of how to take avian flu, which is already highly lethal, and make a few changes to make it highly contagious as well, right? This is relatively easy to do with CRISPR technology. You can imagine, you know, college students doing it. Doesn't matter, right? Keep it very secret, do whatever you can, and if you cause some problems for the industry, that's probably worth bearing the cost. And so I think it's worth asking ourselves in the AI sector, are there nasty use cases, such as self-improving cyber weapons, or one that I'm particularly worried about, which is the use of autonomous vehicles to deliver explosives. We have to be thinking about what are the controls, and I don't think ubiquity is a sufficient excuse for inaction.
Can I respond to that really quickly?
Please.
So I think the products that you talked about copier or Adobe Photoshop. Those are products where companies sell technology for a particular purpose, right? Or a platform. And in those cases, you can absolutely, that company can absolutely put limits in. That's what I meant by sort of the consumers of technology, right? You choose to take algorithms, capability, and put them into a particular product offering and limit it. The question about open source, where you could put code in that would limit it for a particular thing, but the code could be excised. Papers that are published, that anybody could take an algorithm and code that up. You can't, when it's, or semiconductors that do particular sets of things and now can be levered, right? In their general purpose. It's sort of like we've got to control Intel processors so that they can't copy copyrighted movies. Well, at that level, when technology is that pervasive, I'm not sure you can effectively control it. But certainly if you're building services, you're building applications, we can and should, and Google has principles around this in terms of how we use that. I'm just saying when it's pervasive to the point of in every chipset and code that's available completely openly, it's not clear who is able to control that.
Yeah, it's interesting that you mentioned semiconductors because neural network optimized semiconductors are currently on the Commerce Control List, right? The department has already identified this as something that they would like to restrict. And I certainly agree with the distinction you make between the sort of true general purpose capability, like the open source software, and the application-specific implementation. That seems a very natural distinction to me.
I agree with that. Thanks.
Thank you. I'm Najm Meshkati, a professor of engineering and international relations at USC. And here I'm a fellow with managing the Atom project with the Belfer Center. Thanks, Laura, for excellent panel that you have, a great presentation. I have two questions. The first question that I have is, can deep learning and AI do improvisation one day? The reason I'm asking that question because my research deals with complex system failures. I've studied Fukushima Daini, US Airways 1549, and we have seen that, we have published a paper on that, that really what saved the day in the case of Captain Sully Sullenberger and Fukushima Daini, not Daiichi, was really improvisation of the frontline operators. Really, if it was not because of Superintendent Masuda at Daini and they had meltdown, you should have evacuated Tokyo like Daiichi, because it was 20 kilometers closer to Tokyo, or as we know about Captain Sully Sullenberger. And we have seen that, I have seen that in my own research on aviation safety, that even the existing level of cockpit automation has erodes piloting skill. And we have two accidents, Air France 447 and Asiana 213, that were caused by that. And here is my fundamental question. If something goes wrong, if those algorithms cannot figure out what to do, who is there to save the day? Do we have Masuda or Sullenberger there, or what is going to happen? That's my first quick question. The second question, Dr. Henry Kissinger wrote a fantastic article last year and warned about the AI and the end of enlightenment. And he makes a very dire prediction or suggestion or recommendation toward the end of that. I would like to know what is your reaction to Dr. Kissinger's opinion. Thank you.
I'll take a cut on improvisation. Obviously depends how you define improvisation. I think if you define improvisation as making connections between things that you wouldn't have thought were connected and using that insight to do something different. There's a flat surface, it's a river, right? Who thought that that might be something you land on in the Sullenberger case? Then I think machine learning algorithms can do that, because I think that they can correlate things that you wouldn't have thought was correlated. In fact, we saw a little bit of that with Joey Ito's example of the collars, right? That's kind of a clever thing to do, right? In some sense, right? If you happen to see a pattern, right? Sort of criminals always take pictures, right? Where they're not wearing, a sort of collared shirt. and people who aren't criminals don't. Now, that becomes something that, once you know that, right, you can do that. But often that's, I think, you'd say, wow, that's really clever. I think things like AlphaZero, right, which is a sort of something new coming out of DeepMind in the UK, is playing chess in ways that people who play chess are going, I think it's chess, are going, whoa, where did that come from, right? And it's doing that because its representation of the game of chess is different than, right, sort of traditional representations of the game of chess. So I think a certain type of improvisation is possible if you define that as doing something unexpected and maybe connecting together your experience in one area with your experience in another area to apply that. Transfer learning would be the kind of machine learning version of that, right? And again, I think those things are coming. Will it be what a human would define as improvisation or something really clever? I don't know, but I think that there's some overlap there with things that we would probably say, wow, that was clever. How did you improvise that?
There's a kind of flexibility that our current generation of AI machines do not have, which is humans are actually very good at having lots of different conflicting goals simultaneously. And they are very good at recognizing, hey, maybe I should not be working this goal, I should switch to a different goal. So for instance, there are many times when, let's say somebody is trying to optimize some business plan or something like that, and then they realize, oh no, this has some very bad moral effect. And so they switch the goal, even though the job they were supposed to be doing led them to one answer. They realize, well, that's not my only job. I have other goals too that I'm working. And right now, in particular, the generation of technology that we have right now has programmed into it a set of goals. And so one of the things that I think AI will be different, 10 years from now is I think we need to have that flexibility. I think that's partly what makes people better than AIs right now is we're able to switch around those goals. So I think that right now there's an awful lot of extrapolations of the current level of technology. And I've kind of seen this happen before, where people take attributes of the current level of technology and extrapolate that to a super powerful system and assume the super powerful system will have that. And it has extremely bad consequences. But in fact, people are smarter than that, and they are good at switching goals and things like that. And as we begin to deploy such systems and they behave unfairly or they have bad attributes, then I think people will actually be pretty good at changing those systems and adapting the systems and dealing with those problems and so on. So in a sense, I'm much more optimistic than Dr. Kissinger. Not so much because I think that he is incorrect in identifying the problems of the current technology, but I'm much more optimistic about people's ability to solve problems as they arise.
Thank you.
Nick, I think you were next. Yeah, okay.
Thank you to the Belfer Center and the TAP Project and all of you for this expert and incredible panel. My name's Gabriella and I'm from the innovation sector here in Boston. I work for a startup called Global Social Innovation. And my question is more concerned around international development. So I see a lot of AI concentration as far as talent and capability here in the States, especially here in Cambridge, which is really exciting. But I'm curious about kind of like export-oriented artificial intelligence and AI capability. A lot of developing countries in Southeast Asia, in Africa, could benefit from more innovations in technology. And I'm kind of curious from your expertise, what your recommendation would be for the international development space to really kind of capitalize and enhance its capability and innovation through AI.
So I think you'll find that some kinds of AI, the take-up will actually be faster in other places. So for instance, it wouldn't surprise me at all if totally autonomous vehicles, driving happen someplace other than the United States. I think that's very likely, actually. So generally, when people have bigger needs, they're more willing to adopt new technologies and adapt to them and take the good with the bad and so on. So I think you'll see some examples of very rapid take-up and application of these techniques in different parts of the world, sometimes faster than here.
Maybe the way I would say it would be, I agree with that. I think that to some extent, deployment of AI technologies is inexpensive once you've made the initial investment, right? So once you've figured out how to recognize voice or other things, pretty easy to go, sort of put that out someplace. So to the extent that there are applications in the international domain that map over to just using that, those will be kind of globally available and relatively expensive. We see this with like cell phones, right? Cell phone technology is proliferating in places like Africa in some sense because it's relatively inexpensive and quick to do, frankly probably cheaper than doing wine.
Yep.
So I think you'll see that also with AI technologies. To the extent that they need to be customized for that environment or that particular use, then they do rely right now on having lots of data. And I think one of the problems, say, in the developing world would be, are those sorts of data being collected, right? If I say, hey, I want to do driving in this country and the rules there are different, right? And so I need to maybe have some knowledge of those rules that I would say collect through machine learning, or I need to classify a different set of things or a different set of behaviors than what I classify in other parts of the world. Do you have the sorts of ubiquitous data that are available? Do you have millions of miles of driving data and other things from that country? And if not, that may limit the ability of those technologies to be applied in those places. Same thing with government data or social data or other things.
I was just going to say two things. It is easier now for the developing world to rapidly integrate technology than ever before because of cloud, right? That is to say, before you used to have to go build your own organic compute. Now you can just buy it, provided that you have network access, right? So what used to be dominated by large companies and leading Western governments, right, is now available to everybody. And so that allows democratization of these technologies in ways that were not possible before. And that's especially true for AI because many of the techniques in machine learning have been around for a long time. It's just that we now have the kind of compute that enables those things to actually be instantiated in products. So the cloud is the enabling vehicle for that. I would say one other thing, which is if you look, and this won't be AI specific, but if you look at the sectors that have had the least strategic use of technology, whether it's your iPhone,
you can't turn this
you
thing
have
off.
to it needs to obey you, right? That's not an AI
Yeah, just tell it.
don't do that. I don't know if Siri listens to you when you tell her that. Anyway, so my Pixel does, but anyways, the issue is the areas where you have the least amount of strategic use of technology are the areas which are the most heavily regulated. You'll get education, medicine, government, right? Because the regulation enforces a process. And so bypassing the process isn't allowed. That is not necessarily going to be true in the developing world. And so it's possible for process reinvention to happen easier in other areas, in education, et cetera. I think you're going to see the developing world be a place where we're going to learn a lot of lessons. And we can take those skills back into our countries and make those trade-offs.
And I can just say from my previous work at the World Bank, a lot of the countries that previously didn't have a lot of technology built into their systems already were at an advantage because they didn't have to deal with legacy systems and retraining everyone and dealing with all of the problems and switching over with new techniques.
Yeah.
Thanks for the great presentation and conversation. Nick Sinai, I'm an adjunct here at the Kennedy School, teach a tech and innovation in government class. I was also one of the U.S. Deputy Chief Technology Officers in the Obama administration and helped author the 2013 Open Data Executive Order that President Obama signed, and recently got codified into law a couple weeks ago. President Trump signed the Open Government Act, or a piece of larger legislation that says that open and machine readable is the new default for information. And I find this fascinating because the Department of Defense has also now established a chief data officer, and the services are setting up chief data officers. The services and DoD have thought about data as a strategic asset, but this idea of making it open for unexpected innovation is not something that they have always seen it that way. And I'm just wondering, I know you guys are here in your personal capacity, but I'm a huge fan of the recommendations of the DIB. How are you thinking about engaging, nudging the Department of Defense on thinking about data as a open asset to the world for public good and unanticipated innovation? And that could be geospatial data, it could be supply chain data, it could be procurement data. 3 million people, there's all kinds of really rich data sets for possible public good, not just on the warfighting side.
I think it would be good if they would use it themselves first.
Or even keep it.
Or even keep it. I think this goes back to the poverty comment. Every airplane flight that happens where the sensor data is not stored, that flight will never be used to train a model. Every mission that a set of soldiers goes out and their data about position, tactics, sensors, biological data, what's going on, that's not collected. That data will never be used to train a model. So every day that goes by, huge amounts of opportunity cost is adding up because data is not being collected. And partly because the department gets way too little storage for what it pays for, right? It's a different topic. But I think if you have those data sets, and there are areas in medicine and others where they do have a fair amount of data, there are some collaborative activities going on already to work with non-defense entities to sort of share that data and share the learning that comes from that. So I think you're starting to see that in sort of pockets, but you're never going to fix it until the abundance of storage and compute is realized in the department. And we have a long way to go on that.
Let me give you just a specific example of what Milo's talking about, because I think that a lot of people's natural inclination is to worry about the ethics of the overuse of technology by DoD. But actually, I think some of the most serious problems right now are the ethics of the underuse of technology,
right,
where we don't use data that we could do to do the defense job better,
make better decisions,
things like that. And in terms of the poverty, for example, there are many parts of DoD where people have such a tiny limit on the amount of email that they're allowed to store that they spend a significant portion of their time every week clearing out their email. And is that really a great use of those people? Should we be forcing them to do that? Those are the kinds of things, that's the kind of level that we're at now. And I'll pick that one because it's sort of kind of ethically neutral, but it's just kind of dumb. But I think we have lots of situations like that where we're making poor use of existing information technologies. And sometimes that results in actually making worse decisions than we could make otherwise.
And I'm going to say a little about the open part. I would be very careful about thinking about how much of those data to make open, even data that you think, well, there's nothing in these data that are a problem. Because often there are weird correlations and other things that you can go figure things out, right? We see this in the public sector all the time, right? So all of a sudden I can figure out, by looking at, sort of where you were and what you rented from Netflix and other things, right? Sort of, what your job is and what your income level is, and right where you drop your kids off at school, right? And all sorts of things that were unintended, and until you put all of those data together, right? You couldn't kind of identify you, right? So I think I would be careful. So I think we should collect all of those data, because machine learning needs data. That's the fuel for machine learning. We're not collecting those data now. This poverty of compute, poverty of storage, poverty of bandwidth, is a huge problem with the DoD. They got to get over it. I mean, this exists. This is not technology that needs to be invented. It's done. So that's one. But I would be careful about, collecting, yes, making open. I think it's really hard, and the fundamentals of privacy are not well understood, right? And so I would be careful about that.
Thank you.
Hi, my name is Joanna. I'm a research associate at the Harvard Program in Global Surgery and Social Change. I'm currently working on surgical system strengthening in low and middle income countries, focusing in Rwanda, in Africa. I'd like to continue the theme mentioned with regard to international development. I think it's very interesting to highlight the real opportunities that there are in these countries. But at the same time, my question is, what are your recommendations with regard to countries leapfrogging countries in high-income countries such as the UK and America? For example, electronic medical records. A lot of the systems here in high-income countries are actually not very efficient, not very equitable. So my question is, what are your recommendations with regard to leapfrogging, and whether you have any concerns about the leapfrogging in general with technologies such as machine learning?
So I lived in Rwanda as a child. And I think actually this is a great example of some of the things that Milo talked about education. I think education and medicine in both cases where we have a very elaborate but somewhat locked-in system of the way that we do things. And there's a real opportunity in both of those areas to do a kind of end-run in the same sense that cell phones did an end-run on telephone infrastructure. And so I think in those two areas in particular, you will see much more innovative use of kind of AI technologies, much faster adoption. Again, because the need is great. People are willing to accept the limitations of the technology much faster because their alternatives are not as good. And so my guess is that that's where you'll see the fast innovation is in places like that in those two areas.
Yeah, and I would just say, I think there may be limited amounts of reusability of electronic medical record code, for example, from US systems, because we have this elaborate regulatory structure that is sort of defines friction, how to make, where you put friction in that system. Someone who looks at building such a system for a new market, which may not have so much friction in the system, the same sort of insurance structures and healthcare structures, et cetera, may be able to do that in a much faster way, more optimized code that can actually have impact faster. And I think that's going to be an area where I think there are going to be a lot of young computer science engineering folks who who really are looking for impact, can have impact in that education, justice. There's lots of interesting things that could be done in some of these countries, and I'm looking forward to seeing what's going to happen. So I'm more optimistic, I guess.
Yeah, I'm just trying to think about what, is there a reason that one would be concerned about leapfrogging? If I were a country that was able to take advantage of that technology, go do it. And if I were a company supplying that technology, I would want a market where I could go, actually make use of these things in a way that might not be as easy to do in places that have a legacy system, whether that's a regulatory legacy system or a technological legacy system that gets in the way. I think it's, leapfrog away.
I apologize for asking a second question, but I think let me again congratulate the panel for collecting such an amazing group. This is a fantastic opportunity for all of us who are trying to at least put our toe in the water of what's going on. So I want to again ask you about potential applications in the military arena. I think your description of the bureaucratic dinosaur that we call the Defense Department, in which I've worked in and know and love, is accurate. So I don't think there's much chance of it acting more different than the behavior it is displayed in the current activity. So leave that aside. Let's imagine a smart equivalent, maybe China, just hypothetically. And let's take the AlphaGo demonstration of the capability of an applied AI at the margin, or at the current frontier. So the AlphaGo machine, as I bet, or AlphaZero as I understand it, in a matter of a few hours, taught itself to be the world's master of both people and machines in both chess and Go. So there's a fact. Now, I take that capability and I'm an active, intelligent player against the US, let's say China. What possible applications? So one, is this essentially I should win with that capability every competitive game if there's a defined objective function? So air-to-air fight, the pilot should beat the other pilot. Should I win what other competitive games? Maybe even a strategy game. And secondly, imagine I had 21 million files of the security clearances of the people who got security clearances in the last decade, which I was happily stolen by one of my colleagues. Now I have this and I'm searching it and wanting to make use of it. What opportunities do I have?
So I'd say a little about just on the types of games that AIs can help with, et cetera. So first, I'm not an expert on this, but I think both in the case of AlphaGo and AlphaZero, I think it took them much longer than hours to figure out how to play that. Probably months of compute time that went into it. Of course, then that gets encoded, into something that can be executed and play a game. But there's also a feature of that I think kind of gets more to the core of your question, which is, there's a game with well-defined rules that can be simulated, right, in a way that is exact. Right? That is that we can make a model of the way that Go is played or the way that chess is played that is exactly correct. There is no ambiguity there about what the allowable moves are, what it means to win, all those things. And I would say that's rare, because if you sort of say, well, okay, let's do that relative to combat, or let's do that relative to other things. Well, the rules are not clear. People break the rules all the time, right? And so it would be much harder to use those techniques, and in particular, GANs, so generative adversarial networks. So ways in which you say, well, I'll play one kind of machine learning technology against another, right? And sort of one of them is trying to make the other one get confused, and the one is trying to not get confused. That works when you have relatively well-defined rules about what things are. That is, you can replace huge amounts of data with a model that can generate the equivalent of huge amounts of data. So I would look for those as areas where these types of technologies might make a difference in a military setting, and I think they're a little bit more rare. We don't play chess in a military setting for strategy because the rules are much more ambiguous, what's allowed is much more ambiguous, the effects are much more ambiguous, so I think it's harder. Now, if there's lots of data, right, if I can go back and look at 100 years of war and I had all of the data on that, I might figure out strategies from that or things to do, I would say, on that pretty well.
Yeah, I would say a couple things. And first off, the DoD, I think, recognizes its deficit on compute and agility and is trying to deal with that. The Joint AI Center that's just been stood up, I think, is something we've been very pleased with, and I think has the ability to have impact. I would say, it's interesting. If you think about how we do wargaming and simulation, we don't use the technology very well in that context. The large multiplayer gaming environments that could be made with relatively high fidelity could be a great opportunity to try out new tactics, evolve games in a much more complicated environment. The point of AI is to not have to solve the problem through brute force, right? So there could be all sorts of ways of modeling new kinds of engagements, new kinds of weapon systems that could be brought into a system. How would that affect the outcome of a conflict, right? And so I think there's a number of areas. Chinese have also, since you asked about that, have chosen to not build the parity force, but do things differently, asymmetric force structure. And I think that leads to how you model U.S. behavior against a different kind of force is much less predictable. And then we have war reserve capabilities that nominally are are not well known. So there's still a fair amount of uncertainty there. But the one thing I would say I think that's concerning is the ability for them to improve, to lever technology from every commercial sector, and with stolen data, et cetera, and be able to improve their systems faster than we can improve ours. That is a big problem. And I think that's something that we need to be very careful of. There are certain things, certain kinds of engagements where automating the prosecution of the kill chain, for lack of a better term, right? Where you could, for example, have sensors that could identify artillery tubes popping out of shelters and direct counter battery fire before they could get a shot off. There's no way a human being can operate in either the Chinese or the US system doing that. But that, with AI, if you had sufficient sensors, sufficient compute, and sufficient network, DoD doesn't have any of those, but that's a different problem. You could automate that process and say, you know, if you had North Koreans shooting WMD and artillery tubes, you could end that in a much more aggressive way. Those are challenges, right? And it's not just about tactics, it's about the infrastructure that you're using to do the job.
And to Milo's example, and that system will make mistakes sometimes.
Right.
And again, I think we have an ethical and legal structure by which when a human makes a mistake and sort of calls an attack on something that shouldn't have been attacked, we have a structure for dealing with that and kind of doing it. I don't think we know how to do that for a machine learning algorithm
Right.
that made a mistake. Yeah.
Right.
And we may have an adversary who's not particularly as pushing as we are.
Right, they may have a different set of cultural norms about what's allowable, right?
I would have to say something I think is obvious, but you know, we have not won military engagements by trying to be more like our adversaries. We win and generate superiority by being better at being ourselves. And so the question is sort of, I'm not sure the answer is we should just become more like the Chinese. What we should do is try and remove a bunch of friction that prevents us from exploiting our own technologies and capabilities more effectively. Not ethical friction, but Siri, silence yourself.
Turning it off.
Those are the kind of things
Siri
that
disagrees.
Siri
Yeah,
disagrees.
right, exactly.
But I think that's part of the question, right? We've developed many of these technologies ourselves in the United States. Our ability to integrate them and take them into effective, you know, combat operations is a challenge. And so that time, that friction in the system is going to have to be dealt with.
Just as apologies for the response, but Henry Kissinger has asked, in which case did we win since World War II?
I would say the certainly Gulf War,
That's the one.
right?
Just, and the last thing, just to your question about the 21 million security records, but that's a gold mine, right? Because you can look for patterns and correlations in there, right? You know, hey, there are a bunch of people connected to this company. If we tank the stock of that company, we'll affect their income. They'll probably concentrate. I mean, there's all sorts of stuff in there. You know, again, this is this issue of privacy, right? You know, you can make all sorts of interesting connections and inferences.
And so we'll just take these last two questions and then we'll close it up.
So I'm John Haig. I co-direct the Center for Business and Government, most of our Romani Center for Business and Government here at the Kennedy School, and teach here at the school. I also have a private sector background, and then I ran AT&T's international operations. I'll go into some of that. And you know, we've had major technological changes in the past, and society has done a pretty good job of adapting to those technological advances, but they've encouraged that change over an extended period of time. And one of the differences today is that the technology is changing so rapidly, and at least in my experience, policymakers generally can't keep pace with the rate at which the technology is changing. And so it begs a lot of questions about what are the relative roles, at least in my mind and from what I do, what are the relative roles of government relative to industry itself? And I thought Joey Ito did a great job of, you know, the representation and bias, the issues, you know,
Right.
the agency, the privacy questions. But what's the role, the relative role of businesses in addressing some of these issues and self-regulating. Because Joy was also negative about, or somewhat skeptical of the ability to self-regulate. If we don't figure out a way to do that, and given the pace of the technological change, you could just have a Wild West of the implementation of these technologies, and that comes with a lot of variance on the upside and also on the downside, and those can be quite destructive on the downside. So this is partially directed. I know you're speaking as an individual, not as a company representative, but to our friend from Google as to how do these things get played out within a corporate setting.
I would say, as an individual, not representing the company, you know, companies like Google have, at the leadership level, have been tried to be quite thoughtful about the topic. And the AI principles that the company came out with are a guideline in terms of how the company deals with what areas and what capabilities it wants to use, right? The ability to self-regulate depends on your willingness to set principles and stay constant with them and apply them well. I think the question about this is going to be the topic of many boardrooms, right? Because the challenge is the vision of pervasive technology, right? Is I want to get that out and make an impact in many, many people's businesses, lives, et cetera. But I don't want bad things to happen from that. And there is tension there. Google at least has tried to put a stake in the ground with its principles. Parts of them are probably wrong. We'll probably try and fix that over time as we learn, right? I do think it's important that business understand what its commitments and limitations are, where are the guardrails that it wants to put into place, and be thoughtful about those. Without having that kind of conversation, I think you could lead yourself into all sorts of areas which are painful. But it's also fair to say, you're making technology available, just like this conversation about developing world. Anybody with a credit card can go to a cloud provider and gain access to enormous amounts of compute and use that for all sorts of purposes. And how do we deal with those kind of folks, right? They're businesses too, right? And I think that goes back to what kind of tools can we put into place so at least people can understand, be intentional about how they're using their data and understanding what the systems are trying to accomplish. There's probably some role for government in there, but the question is really, what is the goal, right, of regulation or incentive that you're trying to put into place? And is what you're doing going to be effective at creating that outcome? Because there are always secondary consequences. I think it's okay to say we're going to learn over time, we're going to make some mistakes, and we'll get better at it. But if you don't try, you're not going to lead.
I just put a plug in for one other group you might think about in the context of that kind of environmental industry I do. I think the engineering professional societies play an interesting role in many areas, right? As setting what the ethical standards are for that industry. So, Society for Automotive Engineers sets a lot of the standards of what we do in cars, and it's really the industry that's coming together and sort of saying this is what it ought to be, right? To, we have an obligation to society to make cars safe, and then government can adopt those, right? So now you must go out and follow, right? SAE directive, whatever it is. And so there's another group besides just government passing laws. I think industry can, through industry associations and engineering professional societies, have a way to say, here's what our value system is as engineers, and here's the way that should be demonstrated through the product.
Yeah, that was the direction. There was an MIT OECD AI Policy Congress last week, and there was some discussion along those lines at that conference where a lot of industry associations felt they had an obligation to step forward.
Yeah. And I would also just say regulators need to get smarter about the technology. This is, my example about price fixing, right? And algorithms. Well, how are you going to prosecute that, right? What clarity is there about what the law means in those contexts? Presumably, we don't want price fixing to become widespread just because it's being done through a machine learning algorithm, right? So how do you get the appropriate apparatus in place to punish people who are looking for obvious ways around systems using whether it's machine learning or other uses of technology.
Yeah,
I think that's going to be important too.
I mean, I think part of the general direction was that it's cliched a bit, but there need to be more policy people engaged at companies in thinking through with the technologists, and there need to be more technologists on the government side that understand actually some of these aspects.
Thank you. So we'll do one more question in order to end on time. Go ahead.
Good afternoon. Thank you. My name is Wes Adams. I'm a U.S. Air Force officer here as a National Defense Fellow in the Belfer Center. And there were two brief topics mentioned that I'm hoping you can weave back together. And that was on the statement about it's never been an easier time to integrate technology, and then a touch point on culture. And as an Air Force officer, we're being taught about cultural savvy as we go around, we deploy, and we do different things for the country. So I'm curious about your thoughts on the challenges of culture, on AI as a decision-making apparatus when it has to cross over cultural bounds. What are those challenges?
I'll say a couple of things about it. I think too often in DoD there's a culture of no. This is not something we can do. It's not the way we do it, and we need to get by that. We need to figure out how to get these technologies out into the hands of people who can use them and who can improve what they're doing more quickly. And let leaders within the military make decisions about what risks they want to take, right? Because they're at risk, and now I've got a technology that has some risks with it. But really the people who ought to make that decision is the people who are going to use that technology, or the leaders who are closest to the use of that technology. And I think that we often talk as we're going around DoD. There used to be a time when the colonels of the world were the people who were really making those decisions about deploying new technology and other things. And now they're not allowed to do that. There's a huge bureaucracy behind them that's part of the culture of decision making. And I think that's a problem, right? There's a lot of risk that's taken in DoD by not allowing technologies that could reduce risk to be deployed quickly. And so that's a cultural problem, right? The department is not willing to say yes to trying out new things, right, that have some risk, right, but less risk than what we're currently doing.
Yeah, I would say a colonel at the Air Force Academy called it a self-denial of service attack, right? That you're basically not integrating capability that could be material to you because your culture and your process of acquisition, et cetera, simply makes it too difficult, right? I think that's one side of it. I think this bias against automation, is interesting. And the DoD thinks of people as cheap and technology as expensive, whereas industry views people as expensive and technology as cheap. And so, the cost of technology is one of those areas where we have to find ways of implementing technology in cost-efficient ways so that that abundance can now empower humans to lever automation in ways that they can trust, that they can verify, and they can have impact in the mission. I think if you can do that, there were people who didn't believe in stealth, right? And didn't really want to trust it. But after its use in combat, and it was so effective, people embraced it wholeheartedly. So part of the issue is, how do you take capability, build demonstrated impact, and then when people see that, then they don't want to live without it again. And so that's going to be key. Where are the key areas, and I know this is an area where the JAIC is focused, where are the key areas where you can have real mission impact? Prove those out, and then use them as example cases for others to be able to adopt and integrate. Because culture changes when push comes to shove, and you see an advantage in changing. It's not going to change because somebody outside says, that's a bad way of doing it.
I should clarify. I'm a bruised disciple of the culture of no within the DoD. I mean cultural norms, outside, not organizational, international, across countries.
Oh. Okay.
Hi, this is not going to be a question. I'm going to save my questions for another point. But I'm Maura Moran. I'm a partner at Cambridge Technology Law down in Central Square. And as a volunteer, I'm very active in IEEE. And we have an IEEE USA policy committee for AI and autonomous systems, and we're already doing advocacy. We're developing position statements. Chief among them, one of the things that's really primary in the mission is to educate the legislators and be there to provide technological context so that then we can learn from them and make suggestions for them about workable solutions. There's also, IEEE also has the Society for the Social Implications of Technology, which is, I'm going to call it a little bit more philosophical rather than practical bent, but if you want to learn anything more about these, I was VP of Government Relations for IEEE for the last couple of years, and I'm happy to talk to anyone who might be interested in volunteering with us. Thank you.
Thanks so much. And thank you one more time for all the panelists, for all of you for attending. If you're interested in learning more about TAP, go to belfercenter.org/TAPP. Thanks again.